In this next section, we're going to be taking a look at adding or subtracting rational expressions. And adding and subtracting rational expressions is very similar to adding and subtracting fractions. So the rules that you use for adding and subtracting fractions are the ones that you will want to use for adding and subtracting rational expressions. So we have two cases, one where your denominators are the same and one where your denominators are different. So if two rational expressions have a common denominator, you add or subtract the numerators and write the answer as a rational expression with the new numerator over the denominator. So that's a lot like adding two fractions that have the same denominator. All you do is you add your numerators together. So in this case, we have 1 over 5 plus 2 over 5. We add the 1 plus the 2 to get 3, and we leave our denominator as 5, so 3 over 5. In our second case, where the denominators are different, you add or subtract fractions only when the denominators are equivalent, right? So you want to make sure that you have the same denominator. So an example would be if you have fractions like 1 over 6 minus 1 over 2, and you need to pick a lowest common denominator. In this case, we're going to choose 6, because 2 fits into 6, as does 6 fit into 6. And what we want to do is rewrite the 1 over 2 so that it has a denominator of 6. So we leave the 1 over 6 as is, and then we go minus, and then the 1 over 3 becomes 3 over 6, right? Because 3 over 6 is a half, and it has the same denominator as our 1 over 6. And then we can apply the rules to case 1, where we just add or subtract our numerators. And so we're going to go 1 minus 3 is negative 2 over our denominator, which is 6. And reduce, if we can, in this case, negative 1 over 3. So we're going to apply this to a rational expression. Okay, we have 10 over 3x minus 12 minus 3 over x minus 4. And the first thing that we want to do is factor 3x minus 12. Okay, and that's going to give us 3 times x minus 4. Okay, and our x minus 4 does not need to be factored. Okay, and we want to pick a common denominator, okay, between our two denominators here. So what I'm going to do, I'm going to show you using our example up here, where we have denominator of 6 and a denominator of 2, and use prime factorizing to show you where the 6 comes from. Okay, so our denominator of 6 can be written as 2 times 3. And our denominator of 2, of course, is just 2. And the way we choose our LCD when we prime factorize is we always choose the factors that are common to your denominator. So in this case, the 2. And then we always pick the ones that are not paired up. Okay, in this case, the 3. And so 2 times 3 is 6. Now, if we apply that same principle here, okay, our 3x minus 12 can factor into 3 times x minus 4. And of course, our factor of x minus 4 is just x minus 4. And so our lowest common denominator. So just like over here, when we chose the 2 because it was common with for both the 6 and the 2, we're going to do the same thing here. We're going to choose the x minus 4 because it's common to both the 3x minus 12 and the x minus 4. And then we will also choose the 3, the same as we did over here. And so our LCD is 3 times x minus 4. And so in our next step then, we're going to go 10 over 3 times x minus 4 minus, and I need to write this second denominator here so that it's the same as this denominator. Okay? And the way to do that is to times both the numerator and the denominator by 3. By multiplying the denominator by 3, that gives me a common denominator of 3 times x minus 4, which is what we said it should be, right? Right over here. And because I have to multiply this second denominator by 3, I have to multiply this numerator by 3 also, okay? Because I need to keep them equivalent, remember? And that means I have to multiply the numerator by 3 if I multiply the denominator by 3. And so now I'm going to have 10 minus, and then 3 times 3 is 9, so 10 minus 9 over my common denominator, which is 3 times x minus 4. And I now have 1 over 3 times x minus 4, and keeping in mind that our non-permissible value is that x cannot be 4. Okay, so let's take a look at our next example. So when adding or subtracting rational expressions, you can use any equivalent common denominator. However, it is usually easier to use the lowest common denominator. Okay, and that's true whether you're multiplying fractions or rational expressions. Okay, so we want to find the LCD for 3 over x squared minus 9 plus 4 over x squared minus 6x plus 9. Okay, so I'm going to show you once again using fractions and then using our rational expressions. So this example here is very similar to if I had, like let's say 1 over 9 minus 1 over 6. So I have a denominator of 9, which is 3 times 3. And my denominator of 6 is 2 times 3, and I want to come up with the LCD for this. So I choose the two factors that are common to both numbers, okay? And then I choose the ones that are not common to them, okay? And so I'm going to get 2 times 3 times 3, which is 6 times 3, which is 18. Okay, so the LCD for 9 and 6 would be 18. All right, now I'm going to do the same thing for this example here. Okay, my first denominator is x squared minus 9. I want to factor it, so I get x plus 3 times x minus 3. And then I want to take my second denominator, which is x squared minus 6x plus 9, and factor it, and that would give me x minus 3 times x minus 3. All right, so now I want to choose the factors that are common to both of them and then the ones that are not. Okay, and so my LCD is equal to x plus 3 times x minus 3 times x minus 3. Okay, so the LCD must contain the greatest number of any factor that appears in the denominator of either fraction. Okay, so if we take a look at this example here, the greatest number of factors that appears in the denominator of either fraction is x minus 3 and x minus 3. So I have to choose both of those. Okay, x minus 3 and x minus 3. And then if a factor appears once in either or both denominators, include it only once. Okay, so I do have one, that's the x plus 3. It appears once, so I only include it once. Okay, if a factor appears twice in any denominator, include it twice. Okay, so the LCD for this is x plus 3 and x minus 3 and x minus 3. Okay, so that concludes our discussion on lowest common denominators for rational expressions. Okay, so example 1. You will be adding or subtracting rational expressions with common denominators. So determine each sum or difference, express each answer in simplest form, and identify all non-permissible values. So on the first one, you are subtracting a minus 1 over b from 2a over b. When you have a minus sign here, oops, hang on, here, and a binomial in the rational expression that you are subtracting, then it's always a good idea to put a bracket around this denominator because you need to eventually distribute that negative sign through the a and the negative 1. And if you don't put a bracket there, you may not remember. Okay, so that's where we're going to start. we're going to write our numerator together. We're going to go 2a minus a minus 1 over our common denominator, which you can see is b. Okay, so just make a note, use a bracket. Okay, you're going to distribute your negative sign. So you're going to get 2a minus a plus 1 over b. And 2a minus a is a, and then plus 1 over b. Okay, where, and your non-permissible value is that b cannot be equal to 0. Okay, on the next example, there's a plus sign in between. You're adding, not subtracting, so you don't have to worry about brackets. So we're just going to combine the numerators. So 2x plus 8 over our common denominator, x plus 4. And we have a common factor here, right? And the common factor is 2. So we're going to factor that out. We're going to go 2 and then x plus 4. And over our common denominator, x plus 4, you can reduce. And you are left with 2, where x cannot equal negative 4. Okay, and if you can't remember where that comes from, we take our denominator, say it cannot equal 4, solve for x, and so you get that x cannot be equal to negative 4. Okay, in our next example, our common denominator is x minus 2. We have 3 terms that we are going to combine in the numerator because we've got 3 rational expressions. So we're going to combine x squared plus 3x minus 10 in the numerator over our common denominator, which is x minus 2. Once again, you can factor the numerator, and you really should always look if you can, because there's often times that you can. So we're going to factor that, and our trinomial will factor into 2 binomials. So we're going to go x, and then the factors of 10 that will give you 3 are 5 and 2. You want a positive 5 and a negative 2. And then we can reduce here, because x minus 2 goes into x minus 2 once, and x minus 2 goes into x minus 2 once, so you have x plus 5 times 1 over 1. You don't have to write that, and so then you say x plus 5, where x cannot equal positive 2. Okay, and once again, if you want to work out your non-permissible value here, you're going to go x minus 2 cannot equal 0, so x cannot equal 2. Okay, so that concludes our discussion on adding and subtracting rational expressions with common denominators. So in this next example, we're going to take a look at adding or subtracting rational expressions that have different denominators. You are asked to simplify and then express your answers in simplest form. So check to see if you can do any factoring, and it appears that we cannot. We've got 2x over xy, which neither the numerator nor the denominator are factorable. And we have 4 over x squared. There's no worries about factoring that, and then minus 3, so nothing there. So the first thing we want to do is to get our LCD. So we're going to take our first denominator, which is xy, and that's factored into x times y. And our second denominator, which is x squared, which you can factor into x times x. So our LCD is equal to, okay, the first x, and then the x's that we have grouped together, and then the y, and so it's x squared y, so our LCD equals x squared y. So that means that when we go to add and subtract these 3 terms, we will need each term to have a denominator of x squared y. So let's start with the first one. We have 2x over xy. We want our denominator to be x squared y, so that means we have to times the denominator by x, and because we times the denominator by x, we also have to times the numerator by x. And then we have 4 over x squared, So to make the denominator x squared into x squared y, we need to times by y in the denominator and times by y in the numerator. And then minus 3, which does not have a denominator, so if we're going to give it a denominator, then we need to times it by x squared y over x squared y. Okay, and remember that gives us a value of 1. So this is a value of 1, this is a value of 1, this is a value of 1, so we haven't actually changed the overall value of the expression. Okay, so now we're going to simplify our numerators. We've got 2x times x, which is 2x squared. We have 4 times y, which is 4y. And we have negative 3 times x squared y, which is negative 3x squared y, over our common denominator, which is x squared y. And it appears that we cannot factor anything. We don't have a common factor in the numerator, and it's not a trinomial that we can factor. And so we write this as our answer plus our non-permissible values up here. X cannot be 0, and y cannot be 0. Okay, so let's go to our next example. We have y squared minus 20 over y squared minus 4 plus y minus 2 over y plus 2, and we have a non-permissible values of plus and minus 2. So the first thing that you want to do is you want to factor the denominators. Where possible. Okay, and if it were possible to factor the numerator, you might want to check to see if that will make a difference, but we don't have a numerator that we can factor here. So the only denominator that we can factor is y squared minus 4. So we're going to get y squared minus 20 over, and it's a difference of squares, so y plus 2 times y minus 2 plus, and then y minus 2 over y plus 2. The next thing is to determine the LCD. Okay, so the way we're going to do that, we're going to take our y squared minus 4, which has denominators or factors of y plus 2 times y minus 2. And then of course we have y plus 2, which is just y plus 2. So our LCD then is y plus 2 times y minus 2. Okay, so we already have that denominator on our first term, so we can leave that the way it is. But for our second term, we need to multiply the expression by y minus 2 over y minus 2, okay, because that's going to give you your common denominator. Okay, so now we're going to simplify our numerator. Okay, we've got y squared minus 20 plus, and we're going to multiply y minus 2 times y minus 2. Okay, and when you multiply that, when you FOIL it, you're going to get y squared minus 4y plus 4. Okay, and all of this over our common denominator of y plus 2 times y minus 2. Okay, so we're going to combine what we can in the numerator. We've got a y squared and a y squared, so that's 2y squared. We have a minus 4y, and we have a negative 20 plus 4, which is negative 16, and that's over our common denominator. Okay, check to see if you can... Okay, right, sorry, I'm behind all my steps here. Our third step was to write equivalent rational expressions with the common denominator. okay, which we did right here. And then we want to add or subtract, which we did here. Okay, and now what we want to do is we want to factor, if we can, in this case the numerator, alright, because your denominator is already factored. Okay, so what can I do with the numerator? Well, I can start by pulling out the common factor, which is a 2. And I get 2 times y squared minus 2y minus 8 over y plus 2 times y minus 2. And then I notice that I can factor the numerator again. Okay, so I can factor the y squared minus 2y minus 8. Okay, and that's going to give me y minus 4 and y plus 2 over my common denominator. Okay, and then I can reduce, so that would be my next step, reduce. Okay, and so I can reduce the y plus 2 and the y plus 2, and that leaves me with an answer of 2 times y minus 4 over y minus 2, and I include my non-permissible values of y cannot be equal to plus or minus 2. So in this last example, we're going to take a look at a complex fraction. And if you take a look at the top, I've included an example with an explanation of what a complex fraction is. So let's say you have x plus 2 over x minus 3 divided by x plus 2 over x plus 4. You can rewrite this expression here by replacing the division sign with a line. Okay, so you could write our first fraction, x plus 2 over x minus 3, divide it by, and then x plus 2 over x plus 4. So this line, this green line here, means that you're dividing. So this is an example of a complex fraction, okay, where a fraction can appear in the numerator, the denominator, or both the numerator and the denominator. So here is our example. This line here is your division line, okay, and in the numerator then you have 1 plus 1 over x, so here's your fraction, 1 over x. And in the denominator you have x minus 1 over x, so here's another fraction, 1 over x. I mean, it just so happens that your numerator and your denominator share the same fraction. Okay, so I'll highlight the numerator in yellow and the denominator in blue. So for our first method, I'll just call it method 1. You need to find the common denominator in both the numerator and the denominator of the complex fraction. So the common denominator in the numerator is x, and the common denominator in the denominator is x. So your lowest common denominator is x. And what you're going to do with that is you are going to, in the numerator, write the 1 so that it is a fraction with a denominator of x. And in the denominator, you're going to take the x and write it as a fraction that has a denominator of x. Okay, so starting with the numerator then, we're going to go 1, and I need it to have a denominator of x, so I'm going to times it by x over x, and then plus 1 over x. Okay, and in the denominator, I'm going to take my x, I'm going to times it by x over x, and then minus 1 over x. Okay, so in my numerator then, I have 1 times x over x plus 1 over x. So that gives me x over x plus 1 over x. And in the denominator, I have x times x over x. So x times x is x squared over x minus 1 over x. Okay, and I'll continue the work over here. So now in the numerator and the denominator, I have 2 fractions that I can add and subtract that share the same denominator. So I'm going to combine their numerators, so x plus 1 over x divided by I'm going to use a green line for that. X squared minus 1 over x. Okay, so I'm going to take this now and I'm going to rewrite it like what I did up here, okay, where I started. So I'm just going to kind of go backwards, okay? So I'm going to have x plus 1 over x divided by x squared minus 1 over x. And I'll continue the work over here. Now remember, when you divide fractions, you can multiply reciprocals. So you leave the first fraction the way it is, so x plus 1 over x, change your division to multiplication, and then write the reciprocal of your second fraction, so x over x squared minus 1. Now notice you can factor this denominator. So you're going to have x plus 1 over x times x over, and then x plus 1 times x minus 1. And now you're going to reduce what you can. Okay, so you can reduce your x plus 1s, and you can reduce your x's. So in the numerator you now have 1 times 1, which is 1, over your denominator, which is 1 times 1, which is 1 times x minus 1, which is x minus 1, and then write your non-permissible values. Okay, now this x cannot equal x, this x cannot equal plus or minus 1 comes from this denominator here, right? You've got x plus 1 times x minus 1, so x can't be negative 1, and x cannot be positive 1. Okay, so for method 2, I'll just rewrite the question for you. So it's 1 plus 1 over x minus 1 over x. Okay, and our LCD is still x. Okay, so the complex rational expression could also be simplified by multiplying the numerator and the denominator by x, which is the LCD for all the rational expressions. So if you're going to use this method, make sure that your LCD is the LCD for all of your rational expressions. Okay, so we're going to try this, and then you can decide which of the two methods you prefer and why. Okay, so we know our lowest common denominator is x, so I'm going to times the numerator by x. And I'm going to times the denominator by x. Alright, and in both cases, I'm going to distribute the x in the numerator and the denominator. So x times 1 is x. X times 1 over x is x over x. Okay, and in the denominator, x times x is x squared, and x times negative 1 over x is negative x over x. Alright, and I'll bring the work over here. So now what you have in the numerator is x plus x over x, and x over x is 1, so you can simplify that to x plus 1. And then in the denominator you have x squared minus 1, because x divided by x is 1. You can now factor your denominator, so you have x plus 1 over x plus 1 times x minus 1. And so x plus 1 goes into x plus 1 once, and x plus 1 goes into x plus 1 once. And so now you have 1 in the numerator and 1 times x minus 1 in the denominator. And don't forget to include your non-permissible values, where x cannot be 0 or plus or minus 1. Okay, and this concludes our discussion for 6.3.